All right. Good morning, everybody. My name is Dr. Melissa Palmer, and this is Human and Animal Physiology. So I am recording this lecture. I record every lecture. I'll talk about class attendance in just a minute. That's not saying that I don't want you to come to class, but I know things happen, right? Flat tires happen, people get sick. So I try to record every single lecture. If it doesn't look like I'm recording the lecture, I don't mind if someone says, "Are you recording?" Okay, because sometimes I forget and I want to make sure that everybody has access to every single lecture, okay? All right, so today what we're going to do is we're going to just go through the syllabus. Welcome, everybody. I teach a number of different courses here at the U. I have 2 sections of human and animal physiology this semester. I teach a lab as well. For animal science students, I see a few of you guys here. You are required to take the lab. Otherwise, the lab is not required for nutrition students or CBS students, okay? I do have students that elect to actually take the lab, and some of them are TAs for me now. So it's up to you if this is not required, if you want to take the lab or not. It's taught concurrently, so when we're talking about nervous system in the lecture, we're actually dissecting brains in the lab, okay? All right, so with that, let's kind of go through some of the syllabus. Any questions so far? So far, so good. All right. So here is the class format. I do want to just kind of put that out here right now. What we're going to be doing every class period is usually we'll start off with a top hat question. I'll talk about top hat in just a second. Just to make sure that we're kind of thinking about last lecture, reviewing, getting caught up, and then I'll start into a lecture that's usually going to be between maybe 20 and 30 minutes. Usually that gives us enough time to work in groups to do some of the homework assignments. You are required, we have 12 problem sets we're going to be doing through the semester, and you get to drop 2, okay? So, you know, like I said, things happen. I understand that. So just make sure you get in 10 out of the 12 assignments, okay? Today we're going to actually start with the first one. And you're going to be working in groups. You're going to be kind of going through some of the problems as we go along through the lecture. We won't finish this until Thursday, so bring this on Thursday as well, all right? Again, right after the lecture, I like to open up the class to any questions. I really like sophisticated questions, so if you're reading something in the textbook that isn't quite what I've talked about in class, we can definitely kind of talk about that in class. When we get to some of the equations, they're written a little bit differently in your textbook, and I don't mind explaining that to you and why I've written the equations the way I do for this class. Then again, the last part of the lectures are usually some kind of workshop where we're working on either problem sets, case studies. The case studies will usually kind of come later on in the semester. That's when we do more integrative exercises. And then the group project, which I will get to actually on Thursday. I'll talk a little bit about it today, but I'm not going to have you get into your groups until Thursday, until some of the I know there's a lot of adding and dropping right now, so I want to make sure that things settle down before I talk about that group project. All right, so throughout the semester, I get a lot of questions about how to study for this class. One thing that I'll say about physiology is you cannot cram for physiology. It's very convenient that I record every lecture, but can you imagine listening to that the day before an exam? It just won't stay with you. Okay, so the first part is learning the material, and then it's about applying it to these problem sets. A lot of what you'll see on your exam is actually straight from your problem sets. So if you master the problem sets, you'll do just fine on the exams, okay? So the problem sets kind of help you with your mastery of it, and then if you actually Once you've mastered it, I want you to actually make more connections, okay? I want you to be able to really, and that's what your video project is all about. Taking what you learn in the class and then applying it and teaching other people later on. So some of them are going to be educational videos. So again, I'll talk about those video projects in a little bit. All right, so basically what you're going to do is learn about the real world. Then you're going to make sense of your new world and then master the new world, okay? So that's where we're going with all this. Just going back to this for just a second too. I would say the number one thing that's the most important in this class is actually coming to class, okay? I'm going to be talking about everything that will be on the exam. So again, it's really difficult to cram in this class. Everything builds upon itself. All right, so when we're learning about cell physiology, we're going to apply all that to neurons, okay? So coming to class is really, it's like the gym. Half the battle is just getting to the gym. Okay, so I want you to really make it a point to come to class. Again, I record the lectures because I want to make sure that you have all that information before each exam. If you happen to miss a class, I would suggest listening to the recording right away. Don't try to cram everything again right before the end, right before the exam, okay? All right, any questions so far? Pretty good? All right, so let's go through the syllabi. I know this is kind of tedious, but I want to make sure you all have the information that you need. My office is right down the hill just a little bit in Hacker Hall, 225A Hacker Hall. I do hold office hours. This semester, they're going to be Mondays, 2 to 3 p.m., and Tuesdays, 1 to 3 p.m. You don't even have to email me to come to office hours, okay? Just show up, that's perfectly fine. Know that some people are actually making appointments though, so if you don't have an appointment, just wait in line. A lot of times I don't even have students show up during office hours, so chances are you can just walk right in. Otherwise, if it's something really, really important, I would say make an appointment. The way you do that is really easy. Again, you don't even have to email me, just hit this link to my appointment page. So I'm going to go to this particular, show you what that appointment page looks like. Right, so here's the syllabus. Just go to this appointment page. Takes you right to the appointment page, and you can actually click on one of the office hours and just make an appointment. Pretty good? All right. Okay, moving right along. So obviously, and the time you're here, that's wonderful. We do have another section for you guys. Actually, we're cramming all of the information this week into 2 sessions, right? I do have another section that actually goes Monday, Wednesday, and Friday. So just know that it's pretty fast paced. We're going to be going through a lot of material in a 75-minute period of time. All right, so here's how to get a hold of me too. My phone. One thing that I want to mention too is this semester we're using the 15th edition for Vander's Physiology, okay? I really like this book. It's kind of the tried and true physiology book. It's already in its 15th edition. I like it because of its readability, okay? It's actually one book that I would recommend if you're going on to graduate school or health sciences, med school, pre-vet, right, vet school. I would say hang on to this. This is a great reference book. And I wouldn't just say that. This is a great book, all right? So highly recommend you all getting that. If you haven't gotten it yet, get it within the next couple days. And look over the material. I will be updating the syllabus here shortly. The syllabus still has the 14th edition page numbers on it. I actually just got this morning, so I will update the syllabus and then give you a handout on Thursday with the updated page numbers, okay? All right, so is that everything that I needed to cover? Yes, 15th edition. All right, so you do have 4 different exams in this class. Each of them are worth 100 points. So that's 400 out of 600 points in the class. We start off with cell and neurons, cell physiology and neurons. We're going to be learning a lot about electrolytes and how they move across cellular membranes. We'll talk about the resting membrane potential, equilibrium potentials, and I promise it's going to sound, if you're not familiar with this yet, it's going to be a little bit intimidating, but I promise you I'll walk you through it so you feel very comfortable right before the exam. You won't really understand it once I explain it to you. I'm just saying it's very difficult. It's a very abstract concept until you do the problem sets. Okay? Once you run the numbers, it just comes clear. It just becomes clear. Okay? So I'm going to walk you through those problem sets, and then you'll really appreciate how to think about equilibrium potential and how that applies to the resting membrane potential. So everything you learn in cell, right? Cell signaling, we'll talk about epithelial cells. A lot of what you'll learn in those sections, we're going to apply to neurons. Okay, so that's why they're both kind of taught together. The first exam is February 18th. Like I said, we're going to be going pretty fast-paced through this course, okay? But again, I'm not going to test you on anything that we didn't talk about in class. And again, most of the problem sets are what you're going to be tested on the exam, okay? All right, the next section, that's going to take us through spring break up until March 24th. We're going to be learning about muscle. We're going to start with skeletal muscle. And then what we've learned is going to be applied to cardiac muscle, right? We'll talk about it from a cellular perspective first, and then kind of zoom out and talk about the heart as a pump, right? And the vasculature. So you can see how these two are grouped together. Again, that second exam is going to be March 24th, all right? And again, just so you know, what we're going to be learning in cell physiology and in neurons, when we talk about neurons, it's actually going to apply to cardiac muscle as well, because muscle are excitable cells as well. So think about that. Okay, the next section is renal and respiratory physiology. All right, I want to go back and see the last lecture that we have in cardiovascular is vasculature and Starling forces. What you learn about Starling forces is actually going to be applied to renal physiology. So again, it's just a really nice transition. We talk about renal physiology, and the reason why renal physiology and respiratory physiology are coupled together is because they both play a role in acid-base homeostasis, right? They both play a role when we're talking about pH, blood pH, okay? So the third midterm is almost to the end of April, April 21st. And then finally, our last section, which is really the last 2 weeks of the semester, is GI physiology and endocrinology. A lot of people don't realize that GI physiology, there's a lot of endocrine regulation with the GI tract, okay? So that's why they're both grouped together. Very heavy in hormonal regulation, okay? Any questions so far? Stop me at any time. I actually kind of like to run more of an informal class. So if there's any questions that you have during a lecture, I totally appreciate that.
Yeah, so notice you have some lectures like doubled up on the same day.
Yes.
So will we be doing like questions and then lecture and then questions?
That's right. It'll be broken up. The reason why some have the same date is because the topics are the same for the Monday, Wednesday, Friday class, right? And for you all, I had to double up, right? Yeah, thanks. Yes?
Will the final exam be cumulative or on the most recent material?
Yeah, it is not cumulative, okay? It's only on GI physiology and endocrinology. I could make it really difficult if I made it more cumulative, but I don't do that. Now, one thing I do is, I do worry about stress and mental health. I think about that a lot for students. And I realize that sometimes you have 3 or 4 tests in 1 week, which can be very stressful for students. I do allow you to retake one exam at the end of the semester, okay? So what that means is that you do review. You go back and you review. So it's not cumulative, but there's maybe a section that you wanted to do better in that you may go back and review. Okay? Does that make sense to everybody? So you do get to retake one exam at the end of the semester. How it works is during the final 2-hour period, right? Usually you have 2 hours to do the final. The first hour is devoted to the final. And then at the end of that 2-hour period, you get to retake one of the exams. Okay? Questions? All right. So, yes?
Is the retake worth full credit?
It is worth full credit. It replaces the lower score. Yes. Okay. So I'll talk about the points actually right here. This one tells you when your exams are. Your final exam is on a Saturday, 8 to 10. Sorry about that. The 9th. But your last day of class is actually April 30th. So that gives you plenty of time to study for the final. Here's how the point system breaks down. There's 600 points in the class. All right. 400 are each of the 4 exams, right? 100 each, 100 apiece. 50 are for the top hat questions in class. So just coming to class and answering those questions, that should give you 50 points. You'll have 12 opportunities, and again, you get to drop 2 of those, okay? Yes?
So does it matter if we get those questions right or not, or are those participation?
Purely participation, okay? All right. There are 12 opportunities for problem sets and case studies. You get to drop 2. That should give you 100 points. There's no reason why you can't get 100 points, 100 out of 100 on those problem sets, and 50 out of 50 on those top hat questions, right? So the only way that you wouldn't be able to do that is, I think, if you don't come to class, okay? So those are great buffer points. The reason why I'm telling you this is because the exams are hard, all right? I kind of push you because I really want you to do well, and I want you to be well trained in physiology, okay? So the exams are harder, okay? Especially the first exam, I would say it's one of the hardest. Again, just do your best to master these problem sets, and you shouldn't have any trouble, okay? Ask a lot of questions. I do have review sessions. I've even actually organized study groups, okay? So in that way, I really try to push you to learn the material and master it, okay? But again, there's a lot of buffer points built in to buffer any grade that you're not happy with, and you get to retake an exam, okay? Questions? Yes?
If you retake an exam and you do worse than before,
Doesn't matter, low risk. There's no risk to you. You might as well retake it because I'll take the higher of the 2 scores. Yep. So even if you got a 92 on an exam and that's your lowest score, you might as well retake it, right? But I don't know anyone in this class. Let's just say you got a 50 on one of the exams. Imagine you get like a 90 the second time you do it. That's a huge bump in your grade. Okay, so I believe in second chances. I really do. Yes?
Is it the same questions on the first?
It's almost identical. Not quite the same, but it's almost identical. Okay? All right. Okay, so with that, I'll roll this out a little bit later on. We will be using, I won't be bringing paper copies for the exams. You will actually be bringing your computer to class, and you will take the exam on your computer. It will be automatically graded. All right? I used to use Proctorio, but it uses a lot of memory. Some students' computer couldn't handle that. So we're going to actually use another one that just locks down your browser. Okay? And I'll give you more information as it gets closer to exam 1. All right. Let's see. The other one is the group. Oh, question.
Do you need a laptop computer for that, or can you use like an iPad with a keyboard or something?
Oh, that's a good question. I do have like a practice quiz for 1 point, so you might as well try your iPad. We'll just see if it works. Okay? All right. The group video is a fun project. It's a semester-long project. It's only 3 to 5 minutes, okay? It doesn't sound like a whole lot, but on Thursday when I roll this out, I'll give you an example of what some students have done in the past. You can do an educational video, kind of a tutorial for students maybe in the fall semester, something to maybe help with their learning. You can do physiology in the news. You can do a pathophysiological state that reinforces what we learned in class and how things go wrong, how this disease state occurs. Okay, you have to make connections. You are required to find one journal article and a review article to support your video, and you'll be working in 3 to 5, groups of 3 to 5. Okay. Again, semester-long project. Each one of you will be assigned one of the 8 topics: cell, neurons, muscle, cardiovascular, renal, respiratory, or GI and endocrinology. So we kind of spread it out a little bit, okay? We'll get into groups on Thursday. So that's your group video project. No reason why you shouldn't do very well on that as well. Yes?
I guess just one question was, does it have to have your physical body present in the video? Because I've had
No.
a class.
No. You can actually do a recorded PowerPoint presentation, an animation, something creative. The one that I'm going to show you on Thursday is I had some students that were horse experts. They actually made some kind of shawl that actually went over the horse that detailed their whole digestive tract. And they actually talked about equine GI physiology, which was really cool. And I'll show that to you. Yes?
Do you assign groups or do we pick?
You're going to pick, and then I'm going to solidify that. You're going to have an opportunity on Thursday to decide on your topic, your group name, and how many people are in that group. And then I'll assign each different macro topic, and then you can decide on what you want to focus on. Okay? Any other questions? Pretty good? All right, so in this class, we do tend to get a lot of people that get an A and can master all of the concepts. This year, an A cutoff is 93%, so A minus is between 90 and 93. A B plus is 87 to 90. B is 83 to 87, and a B minus is 80 to 83, okay? So just be aware of that as well, and if you have any questions, just let me know. I hardly ever have people that get C's and D's in this class, okay? Unless you just really don't come to class and participate, okay? So again, that's probably the number one thing that will help you in this class, is just coming to class. All right, top hat, here is your number. We may do one top hat question today, but it won't be for points today. It's just kind of a practice run. Your number is 538176. 538176. I did have an email I got this morning that asked about iClicker and Top Hat. I'm not sure how to integrate the two. So for now, we're just using Top Hat. In the bookstore, it's like $22.50. All right, and you will use it throughout the entire semester. And then Canvas, if you're new to Canvas, let me know. I can walk you through our Canvas site. Otherwise, I think everybody is pretty well versed at this particular point in time. Okay, and then the group video project, again, we're going to go through in a lot more detail later on, Thursday. All right, pretty good? All right, so I like to start off with what is physiology. A lot of people think they know what physiology is. Even people that teach physiology, I think if they're not well trained in physiology, they may teach it a little bit differently. I got my doctorate here at the University of Minnesota in the Integrative Biology and Physiology Department. I feel like I'm very well trained in physiology. It is a unique way of thinking about the body, okay? You almost think about these processes like an engineer would, okay? So I'm going to be talking about the major themes in physiology that really distinguish it from other disciplines: homeostasis, control systems, and forces and flows. Okay, I'll get to that in just a second. But these are the three major themes in physiology that distinguish it from biochemistry, from biology. Okay, this is what makes physiology unique. Okay, so we'll get to that in just a second. Some people may teach physiology like structure and function, right? Structure is the anatomy part, function is physiology, right? So you might learn this is the heart, and the heart pumps blood to different parts of the body, right? Sure, that's a good kind of description of what the heart does, but it's not physiology, all right? We're going to be talking about Ohm's law, which is central to physiology. And once we roll that equation out, we're talking about driving force. We're talking about resistance and flow. That's what physiology is. Okay, that distinguishes it from biology. Okay, so that's where we're going with all this. It is the study of life processes, and we're going to take it the approach, we're going to start at the molecular level. We're going to be talking about cells, electrolytes, ion channels, right, first. And then we're going to apply that to neurons, right, muscle. Then we're going to get into the organs and then organ systems like the GI tract. So you can kind of see how we'll zoom out as we go through the entire semester, and it's going to become a lot more integrative. Okay, so then periodically we'll talk about how exercise fits into all of that, right? How living systems respond to physical activity and environmental changes, okay? And then we'll actually be talking, some of the case studies are going to detail some of the disease states or pathophysiological states where things go wrong in the control system, right? So again, if you're thinking about a video project and this is something that intrigues you, by all means, you can come up, talk to me after class in my office, whatever you prefer, okay? It's nice to talk about these video projects up front, right? Get an idea, start to, I can help you form a story, and then go ahead. Don't wait again until the end of the semester, but talk to me periodically throughout the semester just to make sure you feel like you're on the right track. Okay, so we will be talking about disease states and how to treat them. All right, so what do physiologists study? I actually downloaded these slides from the APS. If you're not familiar with the APS, there is a link on your Canvas site. The American Physiological Society, the APS. They're not marketing geniuses. So I just really think this is funny at the very top here. I don't know if you actually see my arrow here. There it is. These are students that, two of them are obviously love physiology, right? One of them in the very corner here, he's not so sure about physiology. And this guy just looks like if I say physiology one more time, he's going to kill me. So anyway, I just think it's hilarious. Sometimes I look at these slides and go, I wonder why they picked that one. But what they do study are plants, animals, a lot of, in this class, we're going to be concentrating on mammalian physiology, right? Most of what I talk about is going to apply to humans and animals, hence the name, right? But we will be talking about crocodiles and birds as well. So there'll be some comparative physiology as well in this class. Invertebrates, insects, worms, we'll talk a little bit about open circulatory system and closed circulatory systems, and then cephalopods. So one of the most famous studies that were done on cephalopods were Hodgkin and Huxley's experiments on the giant squid and the giant squid axon, okay? They were able to elucidate the ionic basis of the action potential waveform in these giant neurons in these squid. Okay, so this is in 1952. They actually won the Nobel Prize for their work, and we are going to actually be talking about this in detail when we get to neurons. Okay, pretty cool. There's also another site that I have on the Canvas website of an overzealous graduate student who really talk about Huxley and Hodgkins, and so you'll have to check that out as well. It's pretty funny. All right, what are some of the things that physiologists do? I consider myself more of a cell physiologist. My work was with epithelial cells and ion channels that were expressed. So here's just an example of what some people who study physiology may do with their work. In this case, these individuals are looking at the difference between heart cells in normal mice or normal rats and those that have diabetes, and looking at the differences between the two electrophysiologically, actually using different techniques like patch clamping, Using chambers to look at different expression of ion channels. They can look at it biochemically, pharmacologically, or using different molecular techniques to look at the differences between these heart cells. So this is just one example of what a physiologist may do. In this class, again, we're going to be talking about how organisms work. The main focus is going to be on function, and then later on in the semester, integration. That's why, again, it's really important to come to class, because eventually we're going to be using all of the information that we've learned in a more integrative fashion, okay? Now, also I want to just mention a lot of these processes at the very bottom here are described quantitatively, which means that there's a lot of equations. The first 3 exams, you will have to bring a calculator, okay? Some people are really well-versed, feel very comfortable with these equations. Other people have come up to me and said, look, I'm coming back to school after 10 years and math isn't my thing, right? So I'm really intimidated by these equations. That's why I actually go through these problem sets in a lot of detail. And I actually help you go through it. I don't just give it to you and just say, you're on your own, okay? I actually help you periodically go through each of the equations, especially when we get to the first exam and we're talking about the Nernst equation. I will help you go through every single question that you can expect on the exam. Okay, so I will walk you through it. Don't be intimidated by it. Not yet, anyway. Okay? Any questions so far? All right, so here we go. Here is really what I want to get at today. Here are the 3 major themes of physiology. And this, again, is what distinguishes physiology from other disciplines. Homeostasis is the first one. Homeo actually means same or similar. And stasis is another term for standing still when you break down that word. Homeostasis. It's actually a process in which the body maintains constancy of its internal environment. Meaning that you have mechanisms in place to maintain constancy of your internal environment. Okay? Mechanisms. And that's where we get to the second one. Those mechanisms are basically control systems. We're going to be talking about the difference between a negative control system, negative feedback mechanism, and a positive feedback mechanism in just a second. These control systems perform the compensatory regulatory responses to maintain homeostasis, which is a relatively stable internal environment. Compensating regulatory responses. So for instance, after you eat a meal, your blood sugar levels are going to rise, and then you're going to release insulin and then glucagon. So you're going to get these a rise in glucose levels, a fall in glucose levels, and then glucagon's going to help you come back to a relatively stable, constant blood glucose level. Okay? So it's a relatively stable. That doesn't mean that there's not oscillations, there's not changes, but it maintains a relatively stable internal environment. And then forces and flows. And I'll get to that in just a second. Okay, so let's start with homeostasis. And I always like to start off, and during my lectures, give you somewhat of a history lesson, okay? Because then you realize what scientists were grappling with during their time and appreciate their genius, really, in coming up with some of these equations or how to think about these processes. When I go to experimental biology, again, the APS is a big part of experimental biology. This is a national meeting that has a lot of talks. Graduate students are always presenting posters. Now undergraduate posters are really a big thing as well. And they always have the Claude Bernard and the Walter Cannon guest speakers, right? So they're already paying homage to basically these scientists. Yes?
Are you going to want us to know, like names and life dates and stuff for the history?
Not this lecture, but going forward, we will be talking about Hodgkin and Huxley again. There's other scientists we're going to be talking about as well. Fick's law, right? We're going to be talking about Adolf Fick. So we'll get into more of some of these scientists in a little bit, but today's lecture, no, you don't have to worry about it. Okay? So Claude Bernard was a French physiologist. He lived between 1813 and 1878, and he was actually the one that came up with the term internal milieu. Okay, I am not French. I don't know why, throughout this entire semester, there's so many French terms, you're going to be amazed. I butcher every single one. So if you're French, please, you can come up and correct me. I don't mind at all. So the internal milieu is what he actually, the term that he coined. He recognized that many animals regulate their internal environment even when there's a lot of changes in the external environment. So this is Claude Bernard. He looks very serious about physiology, right? Okay, so he's telling you to come to class every single day. All right, so the internal milieu is really the extracellular fluid, right? So you have mechanisms in place to actually keep that external environment constant for the cells that dwell in it. Okay? So the internal milieu is basically the extracellular fluid. It surrounds the cells, exchanges nutrients and wastes, keeps those electrolytes constant in the face of changing external environments. Basically acts as a buffer. He also coined the term constancy of the internal environment is the condition for free life. So when you think about it, when you think about things like poikilotherms, like snakes, right, where they can't really maintain a constant internal environment, they're kind of a slave to their environment. To warm themselves up, they have to move into the sun. To cool themselves down, they have to move into the shade. So we, being homeotherms, actually have the ability to control our internal environment. So Claude Bernard recognized that this is the condition for free life. Okay? Walter Cannon is another very famous scientist. He actually studied the autonomic nervous system, and he coined the term homeostasis. He recognized that the sympathetic and parasympathetic nervous system could regulate blood pressure. Okay? And that's what he studied. He realized the importance of the autonomic nervous system in maintaining a relatively constant internal environment. And this is Walter Cannon, much more friendly, kinder, gentler, right? Very nice. All right, so just so you know, these are two famous scientists that really kind of harnessed and described homeostasis and the internal milieu. All right, so formal definitions. This is really the framework for human physiology. Homeostasis refers to the dynamic mechanisms that detect and respond to deviations in physiological variables from their set point values. We'll talk more about negative feedback mechanisms in just a minute. I'll get into a little bit more detail. But they do this by initiating effector responses that restore the variables more towards an optimal physiological range. Okay? Now, this is not a static process. It's actually very dynamic. So whether we're talking about blood pressure or temperature, blood glucose levels, they can oscillate wildly, but these mechanisms are in place to keep them within a certain range. Very dynamic. Okay? And we will be talking about what happens when you eat a meal, when you exercise, how does your body diminish effects on body temperature. And here's another interesting fact too. When homeostasis is maintained, we call this physiology. When it's not, we refer to it as pathophysiology. Okay, this is where you get into the disease states. And it's really, homeostatic systems make adjustments to lessen the internal impact of a major external disturbance. So, with all that information, lots of things to think about, especially as we go through the entire semester. I just want you to keep this in the back of your mind. These are the major themes that you'll be seeing over and over again. So with this, I would say pair up, get into groups of 3. What I'd like you to do is actually think of some examples within your body where homeostasis is maintained. Okay? So lots of different options. We've already talked about a few. I'll give you 2 or 3 minutes. Go ahead and get into your groups and think about some variables where homeostasis is maintained. All right, I detect a little bit of a lull. All right, what do you say? What are some of your thoughts? Now it's quiet. Shy.
You talked about how your blood pressure will like rise when you're working out, so it's like pumping blood through your body.
Sure. Yeah, you definitely have mechanisms in place to keep a constant blood pressure, right? And we'll be talking about the sympathetic and parasympathetic and basically heart rate, stroke volume, those things that really help to maintain blood pressure. Yes. Yes.
We talked about ion concentrations.
Yes. Tell me a little bit more.
Just like the sodium, potassium was what I was mostly thinking about.
Sure. So that is awesome. I love that answer because it's one of my favorite, right? So what we're going to be learning in this class is that basically inside your cells, you actually have very high sodium concentration, and outside high, I got that wrong, sorry. Sodium is high on the outside, potassium is high on the inside. So, not enough coffee this morning. All right, so yes, you have active transporters, pumps that actually help to establish that gradient, and then you have ion channels that help with excitable cells. Yes, perfect. What else? Yes.
We talked about regulating body temperature.
Yes.
If you're shivering or sweating.
Absolutely. Yes. Yes.
The pH of like your stomach.
Yes. Okay. So pH and blood pH. Blood pH is usually between 7.2 and 7.4, and your body does go. You have a lot of mechanisms in place to maintain a constant pH in the blood. You can basically lower the pH in your blood just by holding your breath, right? Your respiratory system can adjust your blood pH in minutes. The kidney does a much better job, but over hours and days. Okay, so we're going to be talking about that a little bit later in the semester. Yes. What else? Yes.
Release of glucagon in the fasting state.
Yeah, right. So basically, your body does a pretty good job of regulating glucose, right? Those energy molecules. Yep. With insulin and glucagon, yeah. What else? A few more. Yes.
Would pain be something that would be part of homeostasis because it prevents you from doing something more to make your body healthier?
I think that's a good one. I didn't have that on my list, but I like that. So if you have pain, let's say you sprained your wrist and you have pain in your wrist, you may kind of favor that for a while to make sure that you don't overuse it. Yeah, I like that. What else? Yes.
The oxygen content.
Perfect, right? So oxygen, carbon dioxide in your blood, absolutely. It is also regulated. Yes. Hormones, absolutely. We're going to be talking about negative and positive feedback mechanisms and how that applies to endocrinology as well. One more that I was thinking about has to do with the kidney. When you think about what the kidney does, how does that it manages certain things.
Cleans toxins.
Yes, right? So waste products, nitrogenous wastes are actually regulated by the kidney as well. So you want to get rid of a lot of those with the urine. So what else do we have? One other thing, when we talk about cell physiology, maybe something that you haven't thought of is cell volume regulation. Yeah, so we're going to be talking about that as well. So here's just a list. I know you all didn't have this in your student slides, but I will post this so that you'll have it now. Temperature, concentration of waste products, gas exchange, pH, energy requirements like glucose, water ion balance, right? Potassium high inside the cell, sodium high on the outside, and then volume and pressure. So also I wanted to roll out the difference between regulators and conformers. Just so you know, regulators actually have mechanisms in place to maintain homeostasis on certain parameters. Conformers actually live in a relatively constant external environment, so they may not have those mechanisms in place. That doesn't mean they can't tolerate changes, right? There are some animals that can really tolerate changes even though they don't have mechanisms in place to maintain that internal environment. Okay? All right, so that's the difference between regulators and conformers. So let's go to some control systems. I'll just briefly go through this. Again, it's something that I want you to recognize as we go through the entire semester, especially when we get to endocrinology. You'll see these control systems. I'll highlight them for you. So they perform the compensating regulatory responses to maintain homeostasis. There are three different parts of any kind of component of a homeostatic system. These are the necessary components. You have a receptor, a control center, and some kind of effector. Okay? So let's go through it. The receptor, if you think about your home heating and cooling system, this applies more for summertime, but we'll pretend we're in 80-degree weather. The receptor is going to be your thermometer. It's going to sense its external environment. It's going to sense the temperature in the room, okay? Now the thermostat is your control center, where you've set a set point. You've actually set the temperature at a particular degree. And if the thermometer and the set point aren't consistent, there's a huge difference between the two. What's going to happen is it's actually going to trigger an effector. So let's just say that the thermometer, right, is sensing that the room is too hot. And it's very different from the set point of 70 degrees. So let's say it's 85 degrees in the room. You've set the temperature on your thermostat to only 70, so there's this huge difference. And when there's that discrepancy, it's going to turn the fan on. Okay? It's going to cool the room down. That's the effector. All right? So once the room starts cooling down and it becomes basically to the set point, now the temperature in the room is 70 and the set point is 70, this is a negative feedback mechanism. It's actually going to shut down the fan. Okay? So again, these are the necessary components of any homeostatic system: receptor, control center, and effector. We've already gone through basically the negative feedback mechanism, but there are other positive feedback mechanisms that I just want to mention. Oxytocin, we'll learn about that at the end of the semester, is one of the classic positive feedback mechanisms. Okay? It's usually really released into your body during labor. Okay? So what happens is oxytocin produces a certain amount of uterine contractions during labor, and those uterine contractions actually cause more oxytocin to be released, right? Which then feeds back and causes the contractions to be greater, right? And that causes more oxytocin to be released. You can see that this is a positive feedback mechanism until some major event like birth occurs, right? This happens during these major events like birth or a pathophysiological state. You get into these positive feedback loops until death occurs, right? So this is what positive feedback means. Now, that doesn't mean that we don't have positive feedback mechanisms in our cells, right, that are normal. It doesn't have to be some major event or something abnormal. When we talk about calcium release within the cells, calcium induces more calcium release, right? And it just keeps the more calcium that's released, the more it induces more calcium release. It just happens to help amplify the response. And that is a typical positive feedback mechanism as well. So we'll learn about normal positive feedback mechanisms too, okay? All right, so here's kind of more of a definition of negative and positive feedback mechanisms. Negative feedback mechanisms, this is where the output, like cooling down the room, reduces the stimulus, shuts it off, okay? It's self-regulating, it helps maintain homeostasis, and our example that we used in class was temperature. It can vary in complexity. Positive feedback mechanisms, this is where the output actually further increases the stimulus. The output acts as a further stimulus, disturbing homeostasis, and the classic example is oxytocin. All right, so the last one here, major themes in physiology, forces and flows. And again, this is one of my favorite. Ohm's law is key throughout this entire semester. I'm going to be referring to Ohm's law over and over again until you're about to throw up, okay? And I will point it out every time. The first thing we're going to be doing is we're going to be learning about if Ohm's law. All of these pertain to Ohm's law from a chemical perspective, a hydraulic perspective, and an electrical perspective. And each one of these have basically the major components of Ohm's law, where the driving force is equal to the flow times resistance. So in this case, the flow is right here, the transport units. This is all describing flow, like a river. Driving force is basically what is pushing those elements around. And resistance is something that is impeding flow, okay? So what I like to start off with is garden hose physiology. Garden hose physiology. All right, so when you think about water flowing through a garden hose, how do you think about it? What's actually pushing the water through the hose? It is pressure, right? The water's always going to flow from high pressure to low pressure. Okay, so that's the driving force. The flow is just the water flowing like a river through that hose. And resistance is if I kink that hose, right? And then the pressure upstream increases, pressure downstream decreases, right? That resistance is part of Ohm's law, so we have to factor that in as well. That's all Ohm's law is. The driving force is equal to the flow times resistance. And you're going to see it over and over and over again. So with the chemical terms, we're going to use this with diffusion, okay? A lot of people ask me, why do you start with diffusion? It seems so random in physiology. But really, if you want to understand electrolytes moving in and out of cells, you want to understand really how the kidney works, because the kidney is all about diffusion and osmosis. I'm telling you right now. You need to know this up front. Okay, so that's why we're going through that. And we'll talk about Ohm's law in these chemical terms. Then we're going to actually move on to the bottom here and talk about Ohm's law with electrical terms. This is going to help you understand action potentials. Okay, and then finally we'll get to hydraulic terms when we talk about blood flow, air flow, right? So we'll talk about Ohm's law in terms of hydraulic terms. Okay, so again, we'll revisit all of this, right, periodically throughout the entire semester. And then we'll do a lot of integrative exercises to bring it all together. And basically, these are the interrelationships. Keep these in mind, for this is how the material in the course has been organized. Okay? Pretty good? Good start. All right, so we have a few minutes. We have about 15 minutes. So I do want to start with the lectures. We're going to start with the first lecture on diffusion. And I'd like to be able to get through the two different perspectives, the continuum perspective and then Einstein's random walk. And that will help you through most of these problem sets, okay? But I will stop periodically to help so that you guys can work in groups and try to figure some of this out beforehand. All right. Any questions? So far, so good. So this is actually L1. So the lecture that I just gave was basically L0. This is really the first lecture, okay? And tab under cell physiology. All right. So here's where we're going. This is basically chapter 4. I'm going to make sure, this book doesn't really change from edition to edition all that much. So if you do have the 14th edition, that's just fine. Obviously, the pages are already correct in the syllabus. I'll go through, and again, I'll give you the page numbers for the 15th edition. But here's where we're going with all this. This is kind of a roadmap of where we're going in the next few days. We'll talk first about diffusion of uncharged solutes, and then we're going to throw in a little complication. We're going to talk about diffusion of charged particles. Okay? So we'll do the uncharged solutes first from the continuum and random walk perspective. Talk about osmosis, which is just an extension of diffusion. Okay? And then talk about diffusion of charged solutes and the equilibrium potential. Okay? Electrochemical equilibrium, and then we're going to use the Nernst equation to calculate the equilibrium potential. I know that means nothing right now, but it will. Then we're going to move into the definitions of current, voltage, and resistance, and that's where we get into Ohm's law, okay? And we'll talk about what the resting membrane potential is and the contributions of conductance and driving force to the resting membrane potential. I know this sounds intimidating at first, but I promise it's going to be easy in the end. It's going to be so routine, okay? Okay, so let's start with some of the learning objectives. I do want you to know the definition of diffusion. Terminology is really big on the first exam, okay? Know the definition of diffusion and understand the process. Understand the factors that determine the magnitude and direction of diffusion, and then write Fick's law. So on your exam, you won't have to memorize Fick's law, but it is something to help you commit it to memory. Let's start off really simply, okay, with the idea of diffusion. If we pretend that top panel is just a big tank of pure water, and we actually add, this is on your left, we add all of these glucose molecules to the left-hand side of this tank. Over time, because of random thermal motion, these glucose molecules are going to redistribute themselves until they're pretty much uniformly spaced out. Okay? That's what we call diffusional equilibrium. Pretty good? Pretty easy so far. So this is all due to random thermal motion, and they're going to be moving in all directions, but the net diffusion is always going to be from high concentration to low concentration. Okay? The net diffusion will always be from high to low. So, formal definitions. Diffusion is the movement of molecules from one location to another as a result of random thermal motion. And this random thermal motion will redistribute the solute from regions of higher concentration to lower concentration until it reaches a uniform concentration throughout the entire solution. Okay? Pretty good so far. So this is a time course, all right? This is a time course of what I just talked about. In this case, here is time A. What you're looking at are, it's like cubes of different solutions. One compartment has all of the glucose molecules in it. 2 is empty. And you can see compartment 1 is the green line, and compartment 2 is the purple line. And over time, they redistribute themselves until you reach diffusional equilibrium. Okay? Pretty good? It basically illustrates that this is the concentration change over time is an exponential function. All right. So here we go. This is kind of looking, we're going to zoom in, and we're going to take a look at this macroscopic view of simple diffusion. Here's what I was talking about from the continuum perspective, okay? So this is how Adolf Fick, in like the 1850s, thought about diffusion. The continuum perspective kind of talks about these molecules moving in a straight line until they collide either with each other or enter through a pore and go across this membrane. All right? So again, it's kind of like billiard balls. Think about it like billiard balls. Moving in a straight line until they collide with another molecule or they move through the pore. Okay? So going back to this beaker right here, you can see one compartment has higher concentration and the other has lower concentration. Now, think about this. Really, this is just a statistical force, not a real force. It's a statistical force. Really? Really what I'm saying here is these molecules, the probability that these molecules are going to collide with each other and move from high to low has a higher statistical probability than these going from low to high. Okay? So you can consider these chemical forces like a statistical force, only about probabilities. So I'll say that one more time because this is important. This is just about statistical probabilities. The probability that these molecules in the compartment that has a higher concentration, the probability that it will collide with another molecule and move across that membrane is higher than it going from low to high. So we can consider this a statistical force. I get this question a lot. Are there molecules moving in both directions? And the answer is yes, right? You do have a one-way flux going from high concentration to low concentration, and a one-way flux going from low to high. So there are molecules moving in both directions, but the net flux will always be from high concentration to low concentration. All right. But Melissa, you're going so nice and easy. And now we come to this slide, which it looks ridiculously hard, but it's not. Okay? So this is Adolf Fick's law of diffusion, about 1850. Okay? And the way he came up with this idea was really interesting. Fourier, a few years beforehand, maybe 30 years beforehand, really came up with some ideas and published his ideas on heat transfer. Okay, heat transfer. So he noticed that if you took 2 blocks of marbles, like a block of, marble, and you put one in the sun and one in the shade, right? The heat would transfer, the net transfer of heat would be from the marble that was much hotter to the one that was cooler. And the surface area between them, the larger the surface area, the greater the heat transfer. Okay? So because of these ideas that Fourier put forth, Fick in 1850s actually decided he could apply this to diffusion. And here is the equation. The net flux is equal to the surface area of this particular membrane. So this membrane in the dark gray in between these 2 compartments, if you turn them on their side, like 45-degree angle, it would be mainly a square, right? So the greater the surface area between these 2 compartments, the greater the flux, the net flux. And multiply that by the diffusion coefficient. That's at the bottom here. Diffusion coefficient is equal to Boltzmann's constant times temperature. The only thing that you really need to know about that is that's the thermal agitation, right? So if you increase the temperature, you're going to increase the net flux over 6 pi r to the 4th. So this d term, the diffusion coefficient, can be put right into this d in Fick's law, okay? So it states in the denominator here, 6 pi r is the radius of the molecule, and v is viscosity. Okay, so viscosity, and I do get this question a lot too, the higher the viscosity, the more it's like syrupy, right, thick. It's harder to basically for those molecules to diffuse. The lower the viscosity, the more it's watery-like, okay? And then multiply the diffusion coefficient by the concentration gradient. Just like with Fourier, the difference between the temperature of those two marble blocks, the greater the heat transfer. The greater the concentration gradient between these two compartments, the greater the net flux. And then finally, this delta X is the membrane thickness. And see these arrows back here? This length between compartment, the outside compartment and the inside compartment, this length is what that membrane thickness is describing. So if the membrane thickness, if it's very thick, what's going to happen to the net flux? It's going to go down, right? Why would it go down? Why would that go down? It's an interesting question. Yeah.
It would lower the probability that one of the molecules could traverse the whole length.
That's right. It actually increases the probability of backscatter, right? The probability that one of these molecules are going to enter into the pore, bounce around, and get kicked back the same side, right? Absolutely right. So that increases the probability of backscatter. All right, so why do we have a negative sign here? Why do we have a negative sign? Yeah. That's absolutely right. So you have a great intuition about it. I'm going to go to this next slide. Because the net flux is always going to go from high concentration to low concentration, it's basically a negative slope, right? So that's why it's describing that. All right, so we only have a few minutes left. Think about the first problem on your problem set. Let's just do the first problem. I'll give you a couple minutes.
Yeah.
So these are due like a week from the day
Yes.
we get them? Okay.
Yep.
Sounds good.
Yeah.
Thank you.
These are usually due about a week after we get them. Just a note too, these are really more about you getting some practice for the exam. So I would suggest that you turn them in on your due date because I will grade them right away and give them back to you. But it's not a hard due date. That doesn't mean don't turn your homework in, right? But I, again, worry about stress and, if you turn it in later, you will get full points for them, but I won't be able to grade them right away. Okay, so just so you know.
Well, if you think about it, the molecules are less viscous, so right? Like if I pour syrup out, it's a lot more suspicious. So within that increases the viscosity of the salt. Yeah, that would well, again, like heat up goes faster. So by decreasing the temperature,
Neurobiology wasn't so much pH, but we were talking about proton gradient.
All right. I have to let you go here in about 1 minute. So we'll pick this up on Thursday, but what I want to say is when you're looking at Fick's law, I want you to realize that everything in the numerator is going to have a direct relationship with net flux, right? Everything in the numerator. That means temperature, concentration, area. When they go up, net flux goes up. However, there's going to be an inverse relationship with everything in the denominator. So when the membrane thickness, the radius, or the viscosity go down, I'm just saying hypothetically, then the net flux is going to be the inverse. It's going to go up. Does that make sense to everybody? Okay, so this is one way to look at the equation and be able to deduce fairly quickly how Fick's law, how that applies to Fick's law. So the equations on the exam, the equations on the exam are really going to look more like this. Then you're not going to run actual numbers with Fick's law. It's just going to be about the relationships between the variables. Pretty good? We'll pick this up on Thursday. Have a good Wednesday. I'll get out of your way. Hi, how are you? Did you want me to introduce you? Sure. Okay, you guys, just so you know, this is Meghna. She's actually your lecture TA. So if you have any questions, you can email me or Meghna. She's actually on the Canvas website as well. So she'll be grading your work.
I won't be able to be here during this lecture because
Yes,
but
no worries.
I get done, like he has us do an evaluation between 11:15 and 11:30.
Okay.
So I usually get done by about 11:25. So if I do have to pick up assignments, I can be here on
Oh,
time.
perfect. That's awesome. Thank you, Meghna.
No worries.
Yes. Okay, so let me just turn this off so I capture.